Sample problem 1.5 is another unit conversions example. So I'm going to be using my T again and working this problem. So let's read the problem first. It says many international computer communications are carried out by optical fibers and cables laid along the ocean floor. If one strand of optical fiber weighs 1.19 times 10 to the minus 3 pounds per meter, what is the mass in kilograms of a cable made of 6 strands of optical fiber, each long enough to link New York and Paris, a distance of 8.94 times 10 to the 3 kilometers? Now, immediately this sounds like a scary problem. There's all these different numbers in here, all of these different kinds of units. It's asking for things. You know, it's really easy to get overwhelmed on a problem like this. But if you follow these steps that I've been mentioning on how to work these problems, it shouldn't be too bad. And remember always, the first step is to write down what we know and also write down what the question is actually asking for. So the first thing that I see here, it says if one strand of optical fibers weighs 1.19 times 10 to the minus 3 pounds per meter. Okay, that's the first thing that I see there, and that's one strand of optical fiber. What is the mass in kilograms? So I'm going to write this down of 6 strands. So what is the mass of 6 strands in kilograms? Mass equals what in kilograms? And I don't like that. Let me fix that a little bit better. There we go. So I'm looking for the mass of 6 strands in kilograms. And what else does it give me? It says each one strand needs to be long enough to link New York to Paris. And it tells me a distance. So let me write that down. 8.94 times 10 to the 3 kilometers in one strand. So I'm going to put kilometers per strand. Okay. So let me tell you a little hint here. Anytime you see a number that the problem has given you, and it has multiple units in it, for instance, that first number there, pounds per meter, that is a classic sign that that is a conversion factor. That will let me convert from a unit of length, being meters, to pounds, a unit of weight. Okay? The same thing with the last one that I wrote down, the 8.94 times 10 to the 3 kilometers per one strand. So that tells me how many, the length in one strand of material. Now, the problem's asking for the mass of 6 strands. So I'm going to start my T out with that. Okay, so 6 strands. That's the value that they gave me that was only had one unit associated with it, right? 6 strands. So that's going to go in the top left of my T. Now the last conversion factor they gave me tells me how many strands is in a kilometer, right? So how many strands is in a unit of distance. So if strands is in the top of my T, always what goes in the bottom of your T is that same exact unit, because I'm trying to get that to cancel out. So I'm going to put in one strand. There's 8.94 times 10 to the 3 kilometers. All right. Now, I always like to do the math with my units first. Strands divided by strands equals 1, so I'm going to cross those out. Anything divided by itself is always equal to 1, right? If I have 2 divided by 2, that's equal to 1. Strands divided by strands, that's equal to 1. So now let me do my math. And remember, everything in the top gets multiplied by each other of the T, divided by everything in the bottom of the T. So, I'm going to open my parentheses on my calculator. 6 times 8.94 times 10 raised to the 3, close parentheses, that's everything in the top, divided by, open parentheses, 1, close parentheses, because that's everything in the bottom, equals. All right, so I got 5, let's see. Oh, let me change my color back to the original one I was using there. So I have 53,640 kilometers. That's the total length of that optical fiber that I'm going to need, right? But we have not answered the question yet. That's the length. The question is asking for the mass. So now I'm going to shrink this up a little bit so I can have some more room to write there. And I'm going to start another T, right? So far I've figured out that I've got 53,640 kilometers. And I need to convert that to kilograms. Now, I have to ask myself, do I have a conversion factor that will get me from units of length to a unit of mass? And I do. This conversion factor right here says pounds per meter. So that's length, that's mass. So I can use this. Now these are not the units that I'm looking for, so I'm going to have to do some converting before I can actually use that conversion factor, but that's okay. So if I check table 1.3 and 1.4 in my textbook, I'll see that kilo, that is a prefix for the base unit of length, meters. And that prefix in table 1.3 tells me that it's 1,000, right? So how I use that table is, since that says 1,000, that means that there's 1,000 meters in 1 kilometer. Now I put kilometers in the bottom because I had kilometers in the top right here, right? And so the one that you have in the top of your T always has to go in the bottom. So now I'm in meters. I'm going to keep going with this T here, because now I can use the conversion factor that the problem gave me, right? And it tells me that in 1 meter, there's this many pounds, right? And so since meters is in the top here, meters is going to go in the bottom. So in 1 meter, there's 1.19 times 10 to the minus 3 pounds. So now I have converted from a unit of length to a unit of mass. Not the one I'm looking for, but I'm on the right track here. So since I'm out of room here, let's go ahead and do the math and see what this is going to be equal to before we do another T. And again, I like to start with my units first. I've got kilometers in the top, kilometers in the bottom. Kilometers divided by kilometers equals 1. Meters in the top, meters in the bottom. That equals 1. Now I'm left with pounds, so when I type this in my calculator, it's going to give me my answer in pounds. So I've got 53,640 times 1,000 times 1.19 times 10 raised to the minus 3. Okay, and I got that is, and I'm going to write it down here because I'm out of room up there, I've got 63831 pounds. And now I've got to convert that to kilograms. So, because the problem's asking for it in kilograms. So if I look on table 1.4, I will see that they're in 2.205 pounds. There's 1 kilogram. And so now pounds divided by pounds are going to equal 1. That's going to cancel out. So I've got my 63,831 divided by 2.205 equals, and I got 28,900, roughly, I'm rounding this, kilograms.